Hello, this is Module 14, Lesson 2, which is eruptions. So when we look at eruptions, if we're talking about eruptions coming from the ocean surface or ocean bottom, it would be basaltic. So magma, the ocean bottom, magma coming up from the ocean bottom is mostly basalt. So anytime we have magma coming up, it's generally basalt unless it's at a subduction boundary. And then we have the plate melting, and then it tends to be felsic. All right, so we look at these types of magma, and so magma is underground, lava is above ground, so that's the only difference between those two. So how explosive a volcano is tends to be, it depends on the composition of the magma. So we've got anything from runny, like the top right picture, to stuff that's really chunky and slow moving, like this bottom picture here. And then we've got temperature. So temperature of the magma the melting point has to do with what the magma is made out of. So basically, rocks begin to melt anywhere from 800 to 1200 degrees Celsius. And so what causes it to change melting temperature is water. So if you have water that's present, then it causes the melting temperature to be lower. And then pressure, so if we increase pressure, that decreases the melting temperature. So increasing pressure causes it to melt at a lower temperature than normal. So that can happen when we have subduction occurring. So composition also depends on how it's going to erupt. So is it going to be really explosive? If it's got a lot of silica in it, it's going to be really explosive. If it has a low amount of silica, then it's going to be less explosive. So sometimes we get volcanoes like Mount St. Helens that are really explosive, all the way down to volcanoes like Kilauea in Hawaii that are very runny and non-explosive. Something that makes them explosive besides the composition is looking at gases. So if there's a lot of trapped gases, it's going to be very explosive. If there's less trapped gases, then it will be less explosive. So the gases that we're talking about in as far as making it explosive would be water vapor, carbon dioxide, sulfur dioxide, hydrogen sulfide. So those are gases that are present in the magma. So the different concentrations would cause it to be less or more explosive. All right, so things to remember as it's becoming more explosive. It's got more trapped gases. And that could be because of water vapor. It could be because of what the magma is made out of. But it just really depends on what melts. So if we look at this picture, basically this graph shows the melting temperature with water. So if you add water, so this is melting temperature for albite with water. So notice how the melting temperature is around 750 degrees. Well, if it doesn't have water in it, then it's more like 1200. So if it's dry versus wet, that's a big difference in melting temperatures. And so that has to do with, when we have subduction occurring, that's generally the ocean floor. And as it's subducting, it's pulling water down with it, and that's decreasing the melting temperature, causing it to melt, and then it rises and forms volcanoes. All right, and then viscosity is how sticky it is. So viscosity is the resistance to flow. So if you think about water has a low viscosity. It wants to flow. It's really runny. Syrup has a really high viscosity, so it's really sticky. It doesn't want to run. So magma that is very explosive has a high viscosity. So that just means that it's really sticky. And think about trying to get syrup out of a bottle. So you have to, or honey, for example, you have to squeeze really hard, and then the honey kind of just comes out. And then water, if you put it in the same jar, you basically just turn it upside down and the water pours out. So same thing with the volcano. If it's really viscous, really sticky, the volcano is going to be super explosive. If it's really runny, then it's not going to be very explosive. It's not going to take a lot of pressure to get that magma out. All right, and so what makes it sticky or not sticky is silica. So silicate minerals are the most common type of mineral. Silica is the second most abundant mineral in the earth. So the abundance of this makes it very sticky. If it's got less silica, then it's less sticky. So the type of magma that is the least stickiest is basaltic. And so this is going to be your runniest. It has the least amount of silica, so it has the lowest viscosity. And so the magma is going to be fairly runny. So this is very common with ocean crust. Hawaiian Islands are mostly basaltic. This is a very dark rock, so that's why Hawaii has a lot of really dark beaches, is because it's got mostly basalt. And so it's very runny, and that's why you can get really close to the eruptions in Hawaii, like Kilauea, for example, is because it's not explosive. It's not going to explode out with tephra material like Mount St. Helens. All right, and then the middle ground kind of magma is called andesitic, and so this would be our gray type of rock. So this is kind of 50-50. So it's kind of half silica, half not. And so this is going to be kind of just an average volcano. This might be an island that's formed by subduction, or maybe land volcanoes. So for example, Lassen and Shasta, they're kind of a mixture of andesitic and felsic, which is what we're going to talk about next. And so they can be both explosive and runny, which makes them stratovolcanoes, which we'll talk about later. All right, and then rhyolitic magma. This is a felsic type magma, and so it's got a lot of felsite, and it tends to be kind of a grayish pink color, and it's got 60% or more of silica. So this tends to be very explosive. So if we were to look at explosive volcanoes like Shasta, Lassen, or Mount St. Helens, we would tend to see a lot of rhyolitic magma. And we looked at this type of rock when we looked at the rock cycle. It's rhyolite. And so this is, it's got a lot of feldspar, which is the pinker kind of rock. And so it tends to be very explosive. So if we were to look at a volcano that we wanted to kind of figure out what type of eruption it had in the past, we would look at the rock type. And so if we saw a lot of rhyolitic magma or rhyolitic rocks, then we would know that the eruption is very explosive. If we saw a lot of basalt, then we would know that it wasn't. All right, all of these, if we look at the different properties, all of the properties make the volcano the way it is. So if there's lots of silica, it's going to be very explosive. If there's water, then there's going to be a lower melting temperature, and those kinds of things. So that just, all of that mixing and where the volcano is and what's happening determines what type of volcano we have. So if the volcano is very explosive, what we're going to have is, and that's very viscous, so very sticky, it'll have what's called tephra. And so tephra is like pumice, or, think of Pompeii, for example, the Mount Vesuvius eruption, really explosive, wiping out Pompeii. And so that's tephra. So tephra would be the picture down here, where you see a lot of like pyroclastic, like the classic volcanic eruption. When you look at like Mount St. Helens, for example, very explosive, and that stuff that's coming out of it is called tephra. And so part of the tephra, or what the tephra is in, is this blast, and this is kind of a not an initial blast. So sometimes it'll erupt a little bit, but this is the explosive part of the eruption. And so this is moving, up to 500, or not 500, but up to 200 miles per hour. And so it's moving very fast. And so this is the pyroclastic material that wiped out Pompeii. This is full of ash, superheated gas. So this is, several hundred degrees or more, sometimes up to 1,000 degrees Fahrenheit. And so that's blasting out of the volcano. It's rock, it's ash, it's you would not survive this. And so, and you could not run this either. So this is moving, 200 to 300 miles per hour. You're not outrunning that or out driving that.
Something triggers a pyroclastic flow about 10 times bigger than all that came before. Within moments, it overwhelms the valley. By the time a TV camera in the village records this scene, Maurice, Katya, and 41 others are dead.